My dear colleagues, time is running out. The Empire is intensifying its attacks against our bases, and we are having great difficulty rescuing the survivors, which is why the High Council of the Resistance is asking us to develop an information system that will help us to assemble rescue fleets with the ships we have at our disposal. And I explain you right now what is the main feature we need to develop here. So assuming we have 5 survivors to rescue, our new product should search for the ships we have in our inventory named Swappy. So Swappy is an existing web service developed with REST. And here, we'll take a particular look to the passengers' capacities of these starships, because we want to filter out the ships that cannot transport any passengers, such as here the X-Wings. Then, on the eligible starships here, we will apply a very complex algorithm to assemble rescue fleets. That algorithm will be based on AI. It means it will have more than 3 if statements in the code, which is the official marketing definition, right? But I will try to popularize this algorithm for you. So here, as you can see, the Millennium Falcon can transport 6 passengers, which is clearly enough for this rescue fleet mission. So we don't have time to lose, and we need to choose right now the architecture for this new product. And I'm suggesting to apply this classic layered architecture with a controller layer, depending on service layer, depending on persistence layer. Who agree with me? Yeah, some people didn't take a look at the title of the talk, right? It was a trap, just to see if any Empire spies were hiding among the ranks. Because although this architecture can be really helpful, it tends to age poorly with time. And I will explain you why. But first, I would like to ask you one simple question. In this architecture, where are we supposed to find the business logic? Service layer. But I also heard something which is also true, everywhere. Because with time, in fact, you will find the business logic in the controller and the persistence layer, because this architecture has some flaws. It does not properly isolate one layer from the other. So it means that sometimes in your data access object, in the persistence, you may have some business logic. So it means that here it will be quite hard to do some unit tests, as you may need to rely on an external framework such as Hibernate. So it would mean that here you need to write some integration tests. And sometimes, maybe you need an external database. And also, if you want to change your database technology, it means that this part of the business logic, you will have to rewrite it. So we have too many coupling at the end. But you know what? The most wicked engineers of the Empire go as far as putting the business logic in the stored procedures, directly in the database. Yeah, I can see people having some kind of post-traumatic stress disorder symptoms, so you know what I mean. Don't do that, it's a nightmare. But the problem is not only about the business logic, because for the technical concerns, you can think that anything related to the database will be in the persistence layer, but since this is a cascading architecture, from the controller, you can see everything, and I'm pretty sure you already have seen people writing some SQL requests in the controller, right? But the thing is, most of the time, we'll see that kind of Spring Boot application. Here we are inside a service layer. I just took one random project on GitHub. And here you see that it has been annotated with Hibernate annotations. So from the service layer, we're actually shaping the database. But also here, you can see that some fields has been annotated with @JSON property, meaning this is a Jackson annotation that helps the controller to know how it should serialize that object over the network. So basically, here, we just coupled the controller, the service, and the persistence layer all together. So if you change your database technology, you might need to change that service layer as well as your controller layer. Too many couplings. But also, some of the fields here are annotated with the adjoint table annotation. So it means that here, if you want to value the tags, you cannot use a unit test. You will need some integration tests, right? Another problem is related to the structuring frameworks we use, such as Spring Boot, Quarkus, and so on, because we tend to put it everywhere, even in places where they shouldn't be. Because if you are coupling your business logic with your framework, and then you need to update that framework to a new version that has breaking changes, such as a minor version of Spring Boot. If some people remember passing from 1.3 to 1.4, it was a nightmare. You will have functional regression, even though you didn't change anything about the business logic, right? Business logic is a kind of algorithm. You don't have to change it for a kind of framework. So it makes that less portable. And keep in mind that someday your backend will become legacy. So maybe 15 years ago, you developed your backend using AGB2 or 3 because that was the main thing at that time. So let's say that backend is still running production, still bringing value to the users. But now, as EGB is no longer maintained, you would like to migrate that to a newer stack, such as Spring Boot, for example. But will it be easy to take the business logic of this EGB application and put that in a Spring Boot application? Yes? No, absolutely not. Because that business logic will be EGB shaped, although it has to remain the same, right? And because this is a simple cascading architecture, when you will have some kind of trouble in the persistence layer, such as a compilation error, the service layer will fall with it as well as the controller layer, like a chain of reaction of errors. So with time, you will have too many couplings in this architecture that will bring too much fragility. So to go over those problems, I would like to introduce you today to the Hexagonal Architecture, which is an alternative that has been coined by Alistair Cockburn in 2001. And we will see that this is a pattern that will help us to better manage software complexity and technical depth, but I will talk about that a bit later. So in Hexagonal Architecture, we want to sanctify the business logic because this is the most important thing in your application. This is actually what is bringing value to the users, and this is actually what is paying your salary, because unless you're working for Spring, you are not paid to write Spring Boot things, right? You're here to solve business problems. So we don't want that business logic to be everywhere. We'll take all these business logics and we put that in a single place. That way it will be easier to write tests that only has one responsibility, the business logic testing, right? In that place, we'll call that the domain. Great. But maybe now you have one question for me. Julien, what's the difference between that domain layer and that service layer we used to have? Can you see it? No, it's quite obvious. You see it? That's the name, obviously. Now, in fact, there is something else. The service layer we used to have has two responsibilities. First, the business logic, I told that already, but it also has to orchestrate deeper technical layers of your application, such as the persistence layer or web service clients. And this is something we don't want in the Hexagonal architecture. We don't want the business logic to be coupled with anything technical. So here we will apply a little trick. Instead of having the domain dependent on the persistence layer, we'll invert that dependency, so the persistence layer will be dependent on the domain. And the domain, we will call that the hexagon. I don't remember why, but it's not really important. And here we've sanctified that business logic, because the domain does not depend on anything else than itself. It also means that here you won't put any frameworks. Frameworks will be only for the infrastructure layers, all the technical parts, for the controller and the persistence layer, for example. But you don't have to reinvent the wheel again, because in the domain, you can put any libraries if you want, only if it shouldn't be that complicated to get rid of these libraries if you need to. And here we have a better software complexity management, because if you remember the theory of software complexity, in the domain we have essential complexity. This is the reason for being of your application, so this is your business logic, the reason why you're doing your application. And on the outside, you have the mandatory complexity, all the technical stuff that are required to make that business logic happen. And remember, if you mix all those things together, you will create accidental complexity that sometimes people call technical debt. So let's do a zoom to see how all those things are working. In the domain, in the hexagon, you will find two sub-layers, API and SPI. API stands for Application Programming Interfaces. And this is a set of interfaces that will help the outside world, I mean the technical part outside of the domain, to call the domain to trigger a feature, for example. So basically, it's made for controllers. So these interfaces are, in fact, the contract of your features, and they must depend only on domain objects. That way, here, no type coming from the left can enter and contaminate the domain. So that way, you will preserve your business logic. So it means that anything related to Jackson, Spring Boot, or even the resources representation, I mean the REST resources representation, those classes, they will remain here in the controller only. The domain will be agnostic from REST. So it will be then easier if you need to add another way to interact with your application over the network, such as here, a RabbitMQ receiver. You just have to create that new module here to use this interface without having to change the domain, because anything related to REST will be there only. As you know, this is message-based, here resource-based, and this is not exactly the same thing. But the domain won't work alone, right? It needs some data from the outside. So that's why here we have the SPI layer, which stands for Service Providing Interfaces. Those are a set of interfaces that help the domain to interact with the outside. The domain defines itself these interfaces, right? So that's why they depend only on domain objects. That way, it will avoid any contamination coming from the right side of the hexagon. So it means that everything related to SQL requests, entity managers, SQL-shaped classes, everything will remain here inside the SQL client, GPA, Hibernate, and so on. So the SQL client obviously has to implement that interface to offer the service of the persistence to the domain. Then it will be easier to add or change your database technology, because you just have to create a Mongo client here that has to implement this interface without having to change both the domain and all the technical layers of the left side here. So this architecture is also called ports and adapters, because all the interfaces here, API and SPIs, are the ports on which the technical layers can connect to adapt, to translate external languages, technical languages such as REST or SQL, into the inner language of your business logic. But enough talking. We'll do a little live code to see how to set up an hexagonal architecture using Spring Boot and Java. So in hexagonal architecture, you have to know that we always start with what is the most important, meaning the business logic. So first, we write the feature, we write the controller related to that, and the persistence if needed. So let's say that we are at the really beginning of the application. For now, there is no feature implemented. So that's why here I only have one single Maven module, which is the domain. And as you can see, it doesn't depend on Spring Boot. Here, the only dependencies I have are JUnit and Assertg that I need for the code. Here you can see that I also defined the model of my domain with a fleet here, which is a record of Starship. And a Starship is something that has a name as a string and a capacity, passenger's capacity, remember, as an integer there. So now I need to code my first feature. But hexagonal architecture is not only today an architecture pattern. This is also a development process, in which here we'll start with a functional test to shape the domain. So we'll do some acceptance test-driven development. Is that big enough? Yeah? In the back? OK, fine. So in that functional test here, I would like to assemble a fleet for 1,050 passengers. When I will assemble that fleet, so basically this is where I need to call the feature of the domain, I would like to make sure that all the Starships all together have enough capacity to transport all the passengers, and also each of these Starships has capacity, meaning more than 0. OK. So here, let's write the code of my feature. I would like it to resemble to that. Assemble a fleet for passengers given the number of passengers. So assemble a fleet here does not exist. Let's create that here as a variable. And because we are using a real language, I need to define a type there. OK. So I want to initiate that to null for now. We'll deal with that a bit later. Assemble a fleet does not exist, so let's create that. Here, IntelliJ is asking me if I want to create that as a class on interface. Any guess what should I use? I can't hear you. Interface, yes, because I'm defining the contract to interact with the domain. So obviously, I need to put that in the production code. And in which subpart of the domain should I put this interface? Remember, there's two. API, yeah, you got it right. Because this is the contract to interact with the domain. So if you don't like API here, you can use features if you want as the name. It's basically the same thing. So here, as you can see now, I have a package API in the domain in which I have my iSymbol of fleet interface, empty for now. We'll populate that here from the usage. Let's create that for passengers method inside. And here, as you can see, it only depends on domain objects such as the fleet or basic types of Java to avoid contamination from the left side of the hexagon. OK. But to be able to execute that test, I need an instance of my assemble fleet, a concrete implementation. So let's define that. Here, let's call that fleet assembler. OK. Let's create that. Obviously, it will be a class here. It's a concrete implementation. Let's put that in the production code. And as you can see, obviously, it has to implement the assemble fleet contract. So let's populate that with what method is missing there for passengers. So basically, here, this is the business logic I need to write, right? So let's do that. As you can see, I'm coding really fast. I don't need AI. So but I'm cheating, right? So here there is two parts in the business logic. First, we need to retrieve the starships from the inventory swappy. Then there is the AI model that would select from some starships here to constitute here the rescue fleet. OK, so let's proceed. Here, first, we need to retrieve the starship from swappy. But remember, swappy is a web service. It's a REST API. So if I want to call that, it means that I will need here to write some HTTP requests. But I'm not allowed to do it here, because this is the domain, right? And furthermore, if someday I'm changing swappy to something else, it's pretty likely that I will have to change the REST API, the way to consume it, right? But the business logic has nothing to do about that. So that's why it should not be there. It will be implemented in infrastructure. So the only thing I can do here is to create a representation of what is my inventory to interact with it. So here, it will be Starship inventory, and I would like it to have a starships method so I can retrieve all the starships. So Starship inventory does not exist. We'll create that as a field there, and let's call that here Starship inventory as the name of the type. So let's create a Starship inventory. Class on interface once again. Interface, because this is a contract for the domain to interact with the outside. So basically, in which subpart of the domain should I put this interface? SPI, yeah, you get it. OK, so let's create that. We have the SPI package in the domain with the Starship inventory. Let's populate here the contract with from the usage. And as you can see, once again, it depends only on domain object. Here, we have a list of starship to avoid contamination from the right side of the hexagon. OK, so here I have a little trick to do just to filter out the starship that doesn't have enough capacity, but it's not really important. And what we have then, yeah, the code you're all waiting for, the AI model. OK. So I will implement that, but don't be too hard with yourself. It's normal that you won't understand what's going on there. And you know what? Don't take a look at the code, right? I said, don't take a look at the code. OK, I'm a liar. There's no 3 if statement there. Sorry. There's a while. It's better, right? So here, it's just a naive implementation that is taking one chip after the other. But it's not the main thing about that talk, right? We hear about the hexagonal architecture, not how to fix that particular problem. So it should be down now for the business logic. But to be able to execute that, here, I need an instance of Starship inventory. But I cannot instantiate that myself, right? Because it will be implemented in the infrastructure. So the only thing I can do here is to ask for a dependency injection that we'll do through the constructor of the fleet assembler there. And we'll see later how we will implement that Starship inventory. OK. But there is a problem there. Yeah, I need to provide here an instance for the test. So even in the tests of the domain, you cannot rely on anything technical, because both the domain and the test must be standalone, right? So it means that here, I don't have any other options than simulating the Starship inventory inside the test. So to do that, I will create a fake referential here of starships, with really small starships and big ones. And I will simply pass that here as a stub, but with a Java lambda, thanks to Java 7. OK. So here, even though this is fake data, we are here to test the business logic. So it doesn't matter this is fake data. We'll test the integration with the real Swappy server later. And now, if I'm executing that test, it should work. Let's see. Yeah, it's working. As you can see, this is green. You have the content of my rescue fleet. Great. So what we have done so far, here we've created a functional test that help us to shape the behavior of the domain, and especially the contract here, assemble a fleet to interact with it. This API interface only depends on domain object, like I said, to create a barrier here on the left. Fleet assembler is the complete implementation of that feature. And because it needs some data from the outside, and it cannot call directly the Swappy server, here we created a SPI, Starship Inventory, which is an abstraction of Swappy. It depends only on domain object to create a barrier here on the right side. So now the domain is contained in a way. And because we want to test that business logic, we created a stub that simulates our Starship inventory. OK, fine. But the next step is that we would like to make sure the business logic brings the value it's supposed to bring. So we'll do an opening on the left, meaning here we'll create a controller to expose that business logic over the network. So let's do a little fast forward. Now you will see that in the code, I have a new module, which is where it's coming. It's there, OK, for the infrastructure. So obviously, this is where we create my controller. As you can see here, that infrastructure depends on Spring Boot, which totally makes sense. Because Spring Boot is made like any other framework to help us to manage mandatory complexity. Obviously, the infrastructure will depend also on the domain to interact with it. On the other side, on the domain, I added something to make sure it will stay isolated. Here, I'm using the Maven Enforcer plugin. And using the ban dependency rule, I will make sure to exclude any dependency. So it means that if by mistake here, I'm adding a dependency coming from any frameworks or outside the infrastructure, the Maven build will fail, right? So you don't have to be that hard. I mean, using a wildcard, you can use instead Maven coordinates to do some fine-tunings. And if you don't like having multi-Maven modules project, you can use instead packages for domain infrastructure and use Arcunic to perform the test isolation of your domain. But I won't have time to show you that. So let's go back to the infrastructure to create the controller. So in the infrastructure here, it's not because we are there that we won't start with a test, right? We'll do some integration test development, driven development. That way, we'll define the contract of our REST API. And as you can see here, I'm expecting to be able to do a post on the rescue fleet endpoint with a JSON. And in that JSON, as a request, I should have the number of passengers, which is 5 for this test. And as a result, I should get a 201 HTTP status created, and also a JSON as a response, in which I should have the ID of the fleet I just created. That should not be empty. A list of starships, and in that particular test, I should have only one ship. That should be here, the Millennium Falcon, with a 6-passenger capacity. OK, so let's implement now the controller itself. So here, I'm using a request mapping here to say that it's mapped on the rescue fleet URL, and a post mapping there that say that that will be the endpoint that will be triggered by Spring. So basically here, what should I write? The way to interact with the domain, right? Exactly the same way it has been defined in the functional test, because in a way, the functional test is taking exactly the same place than the controller. So assemble a fleet, 4 passengers, given the number of passengers. So to retrieve that number of passengers, we'll get that from the request. Thanks to Spring, with the request body here, annotation, it will serialize in that rescue fleet request. As you can see, it's there. OK, so let's take it from the rescue fleet request. Then here, I need an instance of assemble a fleet. So let's create that as a field, right? And here, IntelliJ is asking me if I want to rely on the fleet assembler, which is the concrete implementation, or the contract here, which is the interface assemble a fleet. So on that side, and on that side only, if you don't like having too many interfaces, you can get rid of them and rely directly on the concrete implementation. But personally, I rather like to rely on the contract instead, the interface, because that way it'll be easier if I want to test a controller in isolation without having to rely on external frameworks such as Mockito to stop the domain, right? Because this is a functional interface, I can just use a Java Lambda, right? So it will be easier. So obviously here, I don't want to create that object myself, so we will use some dependency injection through the constructor as well. And we'll see later how it will work. But for now here, as you can see, there is some compilation error. Because the domain returns a fleet, while the controller expects me to return a response entity of that fleet. So response entity is an abstraction of Spring that represents an HTTP response, in which you can put the headers, the HTTP status, and also the HTTP response. So basically something you don't want in your domain, right? Because it's both Spring dependent and both technical. So that's why the controller is an adapter, because it will have to adapt what is returned by the domain, which is purely functional, into something which is technical, which is here a response entity of that fleet. So I'm basically using some factory methods provided by Springs. So here there's created that will create a response entity with the status 201 HTTP. And I'm passing the fleet as the body of that response. So that will be serialized over the network. But as you can see here, there is one problem. IntelliJ is saying that I won't be able to inject my feature in the controller. Why? Because there is no bin registered in the Spring context that corresponds to the assemble of fleet type. OK, so usually, if you want to fix that thing, you go to the concrete implementation, and you put here some annotations such as at component or at service. But can I do it here? No, because this is Spring dependent, right? So what people do to fix that problem, they go inside infrastructure, and in one configuration, what they do some bin factories. So basically, they are instantiating themselves all the objects of the domain, And because this method is annotated with @bin, it will register the return here in the Spring context. But I don't like this option because it's like doing half of the job of the dependency injection framework by instantiating myself and everything, right? So I don't like that. We'll go back to this state because I prefer to rely on annotations. But I cannot use the one from Springs, right? Because they are Spring specific. So we'll apply a little trick that will help us to make sure that the domain won't know Spring, but Spring will be aware about the domain. And it's quite easy to do. You simply have to define your own annotations inside your domain. Usually, I'm not doing that for Spring. I'm doing that from some living documentation purpose. For example, here, I'm creating that annotation named domain service. So if you don't know domain-driven design, it's like a feature if you want. So for documentation purpose, but here, as you can see, I'm using the retention policy runtime. That will help any framework to detect that annotation at runtime. So then I simply have to annotate here my fleet assembler with my own annotation. And I will make Spring aware about this annotation. So you simply have to go inside one configuration and add here a component scan directive that says to Spring, you should scan for this annotation, which is my custom annotation, domain service. And anything annotated with that will be loaded in the Spring context, right? And I will show you that this is working fine. If I'm going back here to the controller, the error disappeared. If I'm clicking here on that bin icon, even IntelliJ is able to find that this is the fleet assembler that will be injected inside my controller. But it's not finished yet, because we still need here an instance of Starship inventory that does not exist. So you have two options. You can create the Swappy client, the real one, or you can create a stub. I will go for the stub, and I will explain you why after that. So a stub of Starship inventory, remember, we've created that already in the functional test. So let's go back to the functional test. And here, as you can see, I just extracted the lambda, and I made that a class. That class, Starship inventory stub, here, as you can see, belongs to the domain. And this is inside the production code. I will explain you why just after that. So as you can imagine, that Starship inventory stub implements the Starship inventory contract, obviously. And here I have my inline referential of ships. So I want that to be used by the controller as well, I mean, by Spring as well. I simply have to create another annotation, like the @stub there. I can here annotate my new class with this annotation. And obviously, what we need to do, make Spring aware about that. So here, let's say, now you have to scan for the stub class, stub annotation. So now, if I'm going back to the test of the controller, if I'm running the test, it should work. So let's see that. Let's cross the fingers. Normal errors, and it is working. Everyone has normal errors, right? The warning's there, but we don't care. So as you can see here, this is working fine. But why did I put this stub in the domain? Because it will help you sometimes to be more incremental inside your development process. Because this application here, you're able to deploy it in one pre-production environment. And even though this is fake data, you should be able to play with the business logic. So here, I have a request, I'm sending that, and as you can see, this is working fine, even though this is fake data. This is a technique I was using when I was working at Expedia. We were working on a rail booking system, and the backend was really bad-shaped. We had to rewrite it from scratch, unfortunately. But the problem was that the mobile teams already have planned to integrate our API. So we made a deal with them. We said, OK, we rewrite the business logic. We will expose the REST API with fake data and deliver it for you in one environment, like a super-wire mock application with real business logic. And they were really happy about that because they were able to start learning about our domain, because they were not rail booking experts. And they were able to give us feedback without having to wait for us to integrate the real train inventory. And that way, it helped us to parallelize the work, because that train inventory, it took us 1.5 months for 5 people to integrate that. But if you don't need that kind of thing to be more incremental, you don't have to put that stub in your production code. You can leave that in the test, right? So just to see that you can have more options with the Hexagonal architecture. OK, so what we have done so far, it was there. Sorry. So we've created an integration test to define our REST API contract. We created the controller, which is using here the assemble of it contract like the functional test. And we just put the stub in the production code so we can deliver that software with fake data to test the business logic. So obviously, we won't live long on fake data, so we need to retrieve the Starship from Swappy. So let's create now the Swappy client. So I would like to show you Swappy first. And this is Swappy. As you can see today, it's not working. So it's a public API, a referential on anything related to Star Wars. And today, they have an invalid date in their certificate. But that's not a problem for the rest of the talk, fortunately. So let's do some live code then. OK, so here, how do we integrate Swappy in the code? As you will see, now I have one package Swappy there. OK? So this is where I will put my Swappy client. But what should I do before creating that Swappy client? Writing a test. Thanks. So here, I have my Swappy client test. Here, when I will call that Starships method on the Swappy client, I would like this to return this list of Starships. But the thing is that Swappy is an external web service. And as you may know, that's a bad practice to rely on an external web service in your tests, because your CI/CD might be flaky if they have any kind of trouble, like an expiring certificate, right? Fortunately, I have a mock server there that simulates Swappy in my test. And this is a real best practice, right? It's not just trolling Swappy anyway. So here, I'm just recreating the Swappy REST API. The mock server should expect a GET on the Starship's URL here and should return with success a JSON. And that JSON is something I just extracted from one response of Swappy. I just inlined it here in a JSON file. OK. And here you can see something interesting. You can discover that Swappy is paginated. OK. So we'll see how we will deal with that. Also, looks like their API is quite generic because they call their Starships results. OK. In a Starship, there is a lot of information. I don't need all these things. I only need here the name and the passengers here, which correspond to what I call capacity. But there is something a bit annoying. Can you see that? The passenger is a string. But I need to sum those things, right? OK. OK, so let's see how we will handle that. So this is a Swappy client inside the infrastructure. So because this is inside infrastructure, I can annotate that with add component or add service. This is normal here. Obviously, it has to implement the Starship inventory contract to return the Starships to the domain by implementing that Starships method. And as you can see, the domain expects us to return all the ships at once. It doesn't care about Swappy being paginated, right? And we made a design choice in the domain, in fact. We know that. I didn't tell you, but I knew that. I don't need my domain to be paginated because I will never return a lot of Starships. And in each of these Starships, there is 2 fields, right? So I don't need that to be paginated. In classic layered architecture, sometimes I see people, because they have an external partner which is paginated, their service layer become paginated as well as their REST API. Doesn't make sense, right? I don't have to inherit the technical choices of my partner. Because if I'm changing to another partner, maybe it won't be paginated. I don't want to change all my application because of that. So thanks to the Hexagonal architecture, this is the adapter that will have to adapt this pagination to return all the Starship at once. So here, let's write the paginated client. OK, caps lock. Here. So I will initiate a list of Starships, empty list. Initiate the next page URL to fetch in the Starship's endpoint. And while this next page is not null, I will retrieve the Starship from Swappy. And I will collect that in the Starship collection, list. And I'm iterating to the next page. OK, so let's implement all those things. So retrieving things from Swappy is quite easy to do. Simple REST template, HTTP client, doing a get on the URL, serializing the response into that Swappy response class. The Swappy response class here is the model of Swappy, which is there, as you can see, right? And it represents, in Java, my JSON response of Swappy. So here, I only mapped the data I needed, so that's why I have a next as a string, with results, which is in fact a list of Swappy Starship. And if you remember, a Swappy Starship is something that has a name as a string and a passengers as a string. While I made a design choice in my domain is that a Starship is something that needs to have a capacity as an integer because I need to sum these values, right? So that's why here in the Swappy client, I will need to convert that Swappy response to the Starship of the domain. This is the adaptation. OK, so let's do that here. So it's quite easy to do. As you can see, I'm retrieving the result from the Swappy response. And this Swappy Starship, I will convert them into a Starship of the domain, taking the name, and passing as an integer the passengers of this Swappy Starship. And thanks to the Hexagonal architecture, this adaptation will be made only in the Swappy clients. The domain doesn't have to be contaminated by the fact that Swappy made a weird choice using here a string. Otherwise, you will have to write a lot of defensive code because, OK, it's a string, so maybe this is empty. Maybe you have some characters that you won't be able to pass as an integer. That's a choice of Swappy. It shouldn't be made in your service layer anyway. And if you are changing from Swappy to something else, which is using a big decimal, for example, why would you change your domain anyway? So thanks to the Hexagonal architecture, all those things are contained in the adapter, right? So we don't have accidental complexity to manage in the domain. OK, so it should pass the test, right? And you know me now. I'm writing code that passes my test, so it should be good that time also. Oh no, what do you see? Sometimes I'm passing NA, and I'm trying to make that an integer. Oh, what's going on? If you take a look here in the Swappy response, we have NA sometimes as the value of the passengers, and sometimes we have unknown. Looks like they have a really bad data consistency. OK, so we'll have to deal with it. And that's not the only point. If we go to the next page there, you will see that sometimes they have 1,000 separators. So it looks like Swappy was made more for front ends and not for external backends, right? But still, the architect has made that choice. I don't have any other option to integrate that inside my application. But thanks to the Hexagonal architecture, all this complexity, like I said, will be made here only in the Swappy client. So I just have to do a little filter. I'm filtering out all the Starships that doesn't have a valid passenger value. What does it mean having a valid passenger value? It means that it's not NA or unknown. Then I need to get rid of the 1,000 separator. And my master gave me a really simple way to do that, pretty convenient. I simply have to replace all comma to an empty string. Yes, it will work well. But as you may have guessed, my master is ChatGPT. Don't do that in production, right? I'm allowed because I'm a professional prompt engineer. OK. So now, if I'm running back the tests, hopefully, it should work. Normal rolls and green. Great. OK. Swappy is dead. But anyway. So here, we wrote an integration test to shape our Swappy client that has to comply with the Starship inventory contract. So it has to return Starship the way the domain defined it. But Swappy made other choices, right? Passengers as a string. So here, we have our Swappy Starship, the model of Swappy, right? That will need to translate to the Starship of the domain. And also, it has to deal with the fact that Swappy is paginated. Everything is contained in the Swappy client. But furthermore, it's not a simple translation, right? Because we will filter out some values. You know, the Starship which have NA or unknown as a passenger value. Because everything you put inside your domain should be functionally valid, right? You can't put invalid data there, otherwise you will have to do a lot of defensive code. So that's why we call that an anti-corruption layer, because we don't want that to corrupt the domain. OK. So let's say we put that in production. This is working well. But we discovered that the survivors, they have to leave behind them the materials because we didn't think about having enough cargo capacity in our starships. So we made a little evolution there. And you will see that now we are taking into account in the Starship the cargo capacity. But there's something which is annoying me there. I have both capacity and cargo capacity, which is confusing, right? So let's rename that capacity here to passengers capacity. OK, so let's do this little refactoring. Do you have any idea why at the end of the talk I'm doing simple refactoring like that? No? Because I can. No. There is an impact there. You know what's the impact of that change? Yeah, I just broke my API consumers, and I will show you that. Because here, if I'm going back to the test of the controller, you will see it no longer passes. Let's see that. That time it should be red. Yeah. As you can see here, the test expect me to, to return a capacity in the JSON, while now I have a passenger's capacity. And why that? Because if you're going back to the controller here, I'm simply serializing the fleet from the domain. So it means that I just coupled my consumers with the representation of my domain, right? And because of that, if I need to handle this breaking API change, I will need to do some REST versioning in the domain itself. Nightmare, right? So what is missing here, and this is a common mistake, I didn't represent what is a REST resource inside the controller. I'm just relying on the representation of my domain object. So to fix that here, now you will see that instead of relying on the fleet of the domain, I'm creating a fleet resource that we build upon a fleet from the domain. And this is where I will be able to do some REST deprecation. Because inside this fleet resource, I have some Starship resource. And inside the Starship resource, I have my new field passengers capacity, but I also have the old one capacity to handle the backward compatibility, right? And I have a map of deprecation. So it's not a real thing to do, that map of deprecation, just to say that you should no longer use capacity and use passengers capacity instead. I mean, you should not do it here for each of these Starship resources. You can put that in one single field at the end of your JSON if you want, but not here. Just it was easier for the talk, but as you can see, I'm telling the consumers not to use any more capacity, but to migrate to passenger capacity. And here, the domain, you see that I'm mapping twice the passenger capacity of the domain once in the capacity of the Starship resource, and another time in the passenger's capacity of that Starship resource. So in the domain, this is clean. There is no mention of capacity anymore, right? So now we decouple the domain with the consumers thanks to this representation of the resource. So that's why here you should not overlook the creation of your resource. It will help you to have an anti-corruption layer between your consumers and your domain, right? And this is where you will be able to do some REST versioning, REST deprecation, and everything else. So this is the big picture of the Hexagonal architecture. I didn't show you, but I also have some integration tests at the application level. But if you want, you can scan that QR code to have access to my repository. I'm Julien Topçu, and I'm a technical coach working at Shodo, a consultancy company specialized in domain-driven design and software craftsmanship. Thank you very much.